Okay, on to a wee recap of trig equations from Nat 5. So, nice and easy getting started. We're going to feed in a wee bit of exact values where possible if you have non-calculator work. But looking at your trig equations from Nat 5. So remember your first step is to rearrange. So we're going to have 2 cos x is 1 and cos x is a half. Now you can see here that we're dealing with non-calculator, so it's going to involve your exact values. So we're going to do the exact same as what we would do in Nat 5. Okay, we have cos, it's positive there and there. RAA, whatever you want to call it. I call it theta. So, cos of what gives you a half? That is 60 degrees. So, therefore, cos x is 60. It is also 360 minus 60, which is 300. And that's your two answers. Okay, so previously, up to this point, we've always had two answers. But this will be extended as we progress, okay? Right, next one. So we're going to do the exact same thing. We're going to rearrange it first. Now you can see this time, still non-calculator, but it is going up to 2 pi. Okay, so we are going to be working in pi. Well, our answer has to be in terms of pi. But I'm going to work in degrees and I'm going to talk about changing it back. So, what we got negative sign is there and there. So that's 180. Now you can again work in pi, right? 180 plus and 360 minus, or pi plus and 2 pi minus. So it's up to you what you want to work in, right? I was thinking it's easier working degrees and then change back to pi. So theta is going to be what we do with sine. Sine to the minus 1 of 1 over root 2, and we're going to put the negative in, which is 45 degrees. Okay, which is pi over 4, we'll deal with that after. So let's get our two answers. Oh, I just realised I wrote cos x last time. X, not cos x. Okay, so x is, what we got? 180 plus 45, so 225. And 360 minus 45, again, you can put this working if you want, 315. Now, what we need to do is we need to put this back into radians. Okay, so we know that pi over 4 is 45 degrees. So we need to work out how many is 225. So, there's different ways to do this, obviously. What you can do is just think about how many 45s make 225. It's 5. Another thing you can do is do 225 over 180. And then simplify it down, and that'll get you your fraction. So that simplifies down, dividing all the way down to 5 over 4. That's another way to do it. So there's different ways to figure it out, basically. Either do 180 and then simplify it, so like divide by 5, divide by 5, or we need to do it all the way down to 5 over 4, or just figure out how do you get from 45 to that. And I'm going to do the same with 315. It's times 7. You can obviously work in terms of pi and then use your fraction knowledge, but a lot of people prefer not to do that, okay, because fractions are messy, non-calculator. So either simplify, put it over 180 and simplify it down, or think it was exact value and then how do you get to the number you're looking for, basically. Right, 14. Now 14 obviously is quite similar to the first one, but you can see this time it's obviously sine, but it's also going up to 720. Okay, so we need to talk about that. So we're going to rearrange it as before. Cast diagram. So again, you're just churning out your steps. It's degrees this time though. Okay, which is 30. So x is going to be 30 and 180 minus, which is 150. However, we have this situation. Okay, so because we have this situation, we have more values. Okay, we're not just going to 360, we're going all the way up to 720. So it repeats after 360 degrees, so we need to think, well, there will be more answers. So what we're going to do is we're going to plus 360 until it gets within this boundary. Until reaches 720. Okay, it can't go over 720 until it reaches 720. So we're going to add on 360. So if you add on 360 to that, you get 390. If you add on 360 to that, you get 510. If we add on 360 to our 390, you can see it's going to be too big, right? It's going to be 750, so then we're done. You can leave it like that if you want, or you can just write them in a line. So the boundary is important because we're not just always going to be looking at between 0 and 360. We do have to think about what is happening. Okay, last one, 14. So we're going to rearrange it. You see it's got a squared in here though. Now what's really important is when you square root something, which is what we're going to be doing. Okay, what happens? We get two answers. Positive. And we get, I wrote a negative first, don't really matter. Negative and positive. Probably do positive first. Okay, so whenever you square root something, remember you get two answers. So let's work with this first one. Now, this isn't on calculator. That means it's going to involve exact values. I'm going to tweak this though. So if you're square rooting a full thing, remember, you can square root at the top and square root at the bottom. Which makes more sense because then we can see, oh, that's like your exact value. And then we're just going to work through both of these as you would do. So S, A, T, C. So we're doing with a positive on this side. So there and there. Cos to the minus 1 of root 3 over 2. So cos to the minus 1 of root 3 over 2 is 30 degrees. So on this side, we're going to have 30 and 360 minus, which is 330. And then over here, we're still going to be using that 30, but obviously we're going to have the negative of it. The negative quadrants, which are these two. So 180 minus, and then 180 plus. So 150 and 210. But our question is in radians. Okay, so we need to put all these back into radians. So we have, and I'm going to put them in order. And then we're going to go back the way. Right, so we know that pi over 30 is pi over 6. Okay, so 150 is 5 pi over 6 because it's 5 times that. That's 7, this one's a bit easier. 7 pi over 6 because it's 7 times 30, and then that's 11 pi over 6.